Right, I'm going to discuss how the ionization energy changes across the period. So what happens across the period? You have your same shell going on, but the shell is getting smaller and smaller as you go across. This is from periods. This is from groups 1 to the last one, 8 groups. So 1, 2, 3, 4, 5, 6, 7, 8. So it doesn't count the transition metals for now. So for group 1, you have 1 electron in the outer shell. Group 2, you have 2. Group 3, you have 3. Group 4, you have 4. Group 5, you got 5. Group 6, you have 6. Group 7, you got 7, which is your halogen, and so on, okay? And group 0 or group 8, you got 8 electrons in the outer shell, so it's got a full outer shell in there. So the thing that you see in here is that the shell does not change. It's still the same shell, but electrons being added as you go across. So what happens is if you have electrons, so there'll be more electrons. The reason why ionization energy increases because there's more electrons being added across the period. Therefore, there's going to be more protons in the nucleus as you go across the period. So if you got more electrons and you got more protons, you're going to have a greater attraction from the nucleus and the outer shell electrons. So the radius will decrease, and the last electron that you're trying to remove will be closer to the nucleus. Therefore, electron is closer to the nucleus, and it is harder to remove. Therefore, ionization energy increases across the period. But this is a regular pattern, but it doesn't go across exactly as it is. We'll talk about that in a bit later. Thank you for that.